So what I said is that if you apply a force to an object, it's going to accelerate, providing the overall force or the resultant force is not zero, it's going to accelerate. You can calculate that acceleration using this formula and then rearranging it to acceleration is equal to the force divided by the mass. So that, in other words, if something's heavier, something's got a larger mass, the acceleration is going to be lower. And that makes sense, doesn't it? You can visualize if you were trying to push a big, massive boulder, it's going to get faster and faster, but at a slower rate than if you did it with a lighter thing. So acceleration is, we can therefore say that acceleration is inversely proportional to mass, which basically means if I increase the mass, the acceleration decreases. And we can say the acceleration is directly proportional to the force. And so if I increase the force, more specifically, if I double the force or triple the force, the acceleration is going to double or triple. So the acceleration is directly proportional to the force. It's inversely proportional to the mass. And acceleration means how much the speed or the velocity is going to increase every second. So 2.5 meters per second squared means that every second the speed or the velocity is going to increase by 2.5 meters per second. So if it started off at 0, after 3 seconds, it's now going to be at 7.5 meters per second. After another second, it's going to get up to 10 meters per second if we started off at 0. If it didn't start off at 0, it would just increase by about this amount. So let's say the starting velocity was 3. It went from 3. Then you add 7.5, so it would be now at 10.5 meters per second. Okay. Now, what we can do, this brings in some symbols here. What symbols have I used so far? We know about F, we know about M, we know about A, and we know about T, and we know about V. I'm going to use just a couple more. U is the initial velocity. If we have a situation where there is two velocities, so a starting and a finishing velocity, of initial and a final velocity, then U is the initial, and this one is the final velocity. And then I'm going to bring one more, which is annoyingly S, which is basically it's called displacement, and displacement is like distance. Like velocity is like speed, displacement is like distance. Basically, it's the vector version of distance, and velocity is the vector version of speed. So we won't go too much into vectors and scalars right away, but that's the basics of it. Okay.